Hello everybody. I'm putting this video together for those of you who would like some additional help on the 5th programming assignment for CO117. And what I'm going to do here is just sort of overview the assignment and show you some of the code and some of the way that I've got things structured. And hopefully this will help answer some of the questions you might be having on various parts of this assignment. So that's my plan. So what I've got here on the left side, I have the project, and it's all contained within one file called bank.java, and I'm of course running IntelliJ here. And on the right side, I have the assignment document. And so I wanted to point out, I did update the document on the last page where it says sample output. I didn't really like the data I was using, and I think at one point when it wanted a balance, I put in a %, and it just didn't make sense. And so I went back and revised the graphic on the sample output. That's the only change that I made. So if you haven't already done so, go ahead and download that document again and replace it. What you see here, when this menu comes up, of course, the user can create a new customer, view an existing one, or exit the program. And I have them creating a new customer here. And as you can see, that the program prompts for the name, a customer number, and then it asks 3 questions. And the user doesn't have to provide these accounts for the customer. It's completely optional. You can create the customer with no accounts at all, or any combination of the 3, but there can only be one checking account, savings account, and money market account for a customer. And for each account type, it's asking for an opening balance, but for the savings account, it also asks for an APR, which is an annual percentage rate. And then for a money market account, it needs an APR, and there's also a minimum balance that's enforced. And rather than asking the user for that minimum balance, I just went in and hard-coded in the main method that minimum to 1200. So I print that out for the user so that when they do enter a balance, it actually shows that minimum amount. And if they try to enter a number under that, the program actually asks them to repeat entering the value. So they have to enter a different number that's, that fulfills that minimum balance requirement. And it saves the customer, as you can see here. And then it also shows a detail report, which basically just prints out the name of the customer. It puts their account number in parentheses with a £sign in front of it. And then it just shows each account. Now, notice it uses a prefix for each account type. And then I hard-coded the account numbers, and I'll show you this here in a minute, but I hard-coded them in so they just show up 1, 2, 3. And then here are the balances for the accounts. Then the user comes along and decides to view an existing customer. Well, there's only one to view at this point, but they enter the account number, the customer number, and then it brings up the same detail report that they had seen when they added the customer. There is no capability of deleting a customer here or making any changes to a customer. We could have done all of those things, but it would have made the assignment a little bit too big, so I just decided to leave it here at this point. It's really sort of an initialization program, just getting a customer into the system with some default values, and then some other program would handle, the day-to-day work or maintenance of those customers. So let's take a look now at the UML diagram. So here's the UML diagram, and as you can see here, we have a customer in the upper right corner. This customer class, as you can see here, the properties are customer number, customer name, and customer details. The legend puts a P on these, and by properties, what they really are saying is that it's a field that is encapsulated by a getter and a setter, or at least a getter. So for instance, customer number has a getter and a setter, thus the red and green dots. Customer name also has a getter and a setter. Customer details is a read-only property because it basically creates a string that takes some of the other attributes and just puts them together and just shows you the results. So get customer details is a read-only, thus the green dot. Now it doesn't put here the get customer number, set customer number. It doesn't show the get and the set. Those are implied by the fact that it's a property. In the IntelliJ IDEA nomenclature for a UML diagram, a property, or a P here, again, it implies, or I should say it assumes, that you've created a private field and that you have created a getter and or a setter for that field to expose it. If you've only created a getter and not a setter, you'll only see the green dot. The green dot, which is the getter, is a safer of the two. The setter, which actually changes data, is in red, which makes sense. So there is one field that doesn't have getters and setters to encapsulate it. And that field is the accounts field. So up at the top where the F is located, you'll see the word accounts there. That is my private variable named accounts. It's an array list that can hold account objects. And it's private and it doesn't have a getter and a setter. So rather than have a get accounts and a set accounts, we don't want the user to deal with all of the accounts all at once. So rather than having a simple getter setter, we create an add account method in here, and we could have put in an edit account or a delete account or something like that. For the purposes of our assignment here, we kept things simple and we just said, look, if you want to add an account, you can call this method to do it. You pass the account into the method and it adds it for you. What kind of an account are you adding? Well, you could add anything that's an account, which includes checking, savings, and money market. All three of those extend account. Now, money market extends savings, and savings extends account. So indirectly, money market extends account. Therefore, what you're seeing here is polymorphism at work, in that you can add an account, and Java expects you to give it an object that is an account class. Is checking an account class? Yes, it is, and yet it's more than just an account class, but it is. So it's almost as if to say, add account, you pass in an object that's a member of the account family, and all of these classes they belong to the account family because they all inherit from it. And that, in a sense, is polymorphism. It doesn't care what type of account you're adding. It doesn't need to know, in fact. It just needs an account of some type. So this is a more general expression of something that you're actually giving it that's more specific. And you don't care about the specifics. You just are concerned that it's an account. Now, save customer and load customer are static methods. Notice the little shape in the corner there. So we can go directly to the customer class and say customer.saveCustomer and pass to it an actual customer object. We can also call customer.loadCustomer and pass it a customer number. Another way of doing this would have been to create a method that was not static and just call it save customer. And it would take itself, the customer object, and save itself out to a file. And then load customer could have gone out and retrieved a customer and put it into the object in which the method existed. However, it would still require a customer number to know which file to go to get the information and pull it in. But it kept them static so that they were independent of any specific instance of a customer. That really makes them more like utility methods, and it decouples them from a specific object, which gives them a little bit more flexibility in terms of how they can be used. And I'll show you that in a little more detail later, but there is a reason. It's not critical to do it that way, but it's helpful to do that way in most cases. Then we have a toString method, and we have two constructors. One takes the customer's name and the account number, and the other is a default no-op or no operation constructor, which doesn't initialize anything. So let's come over and expand out the customer class over here. So as you can see, I have my private customer name and number. I have a private array list called accounts. Notice that I new up the array list. Notice here the tilde. If you notice that there, in later versions of Java, they, instead of putting account here and over here, they enable you to put a tilde there. And that tilde takes what's over here and references it in. That's a very new feature, a very recent feature they added into the language. So you may or may not encounter that. We have our no-op constructor, and we have our constructor that takes the name and number. The constructor just takes the data, passes it right into the field directly. It doesn't call set customer name and set customer number. It certainly could do that. What you're doing here is you're overruling the setters. The setters don't do any validation. If you look here, here's your set customer name and your set customer number. There's no validation going on inside of there. They're just taking the data that you present to them and dumping them right into the fields. Now, one could argue that it would be better to call set customer name here, like this. Now, when the object is created and the constructor is called and these two variables are passed in, they're going to get routed through the setters now. And the setters, even though they don't provide any validation presently, they may in some future point. And of course, if they do have validation in them, they will probably be capable of throwing an exception, which means that the customer constructor will have to be able to throw exceptions as well. But the getters and setters on this are very straightforward. You can see they're all listed here. Then when you get down to add account, this is a place, and a lot of these methods are this way. You're going to expect an account to be passed to this method, and the account we're going to label A. However, it's possible that A may be set to null. And so if A is not null, then we attempt to add the account to the array list. Now this may trigger an exception. There may be some other issue or some reason that fails. Because the method throws an exception now, that will be okay. It will be handled by whoever called the method. If A is null, we will throw explicitly in this method on line 357, we new up an exception object, and we initialize it with a string that goes into the constructor, and we throw it. When we throw the exception, it needs to be handled by whoever called add account. And I say that with a caveat. If the procedure that called add account does not handle the exception, then whoever called its method must handle it. And on the way up the chain it goes, somebody has to handle that exception in the program, because we explicitly stated here, you must deal with that exception. My save and load customer methods are not complete. I did not implement these yet. But you'll notice they are both static, and At this point, they don't throw exceptions, but they probably would ultimately when I build them. They would have to be suffixed with a throws exception on the end for both save customer and load customer. Get customer details, it just simply returns back information, and if you look here, it starts by printing out customer detail report, and then I'm taking the string called show and I'm just concatenating things onto it continually. Here I'm taking a string and I'm formatting it using these format codes to put the name and then parenthesis and then a pound and then another insertion. This is called a substitution parameter. This one carries you over to this .customer or get customer name, and then the second one takes you over to get customer number, and it plugs the values into those appropriate places. Notice here this for loop. This is a special type of a for loop which operates on what's called an iterator. And what it's going to do is it's going to go to the accounts array list, and it's going to pull every single account object out of it one by one. Whatever one it happens to have pulled out, it's going to call it A. That's just a temporary name it gets. So it loops through every single account in the array list, and when it pulls one, it calls it A. So all this is doing is it's displaying the object A and rendering it as a string, but it's putting a tab in front of it first before it shows the data. And what that does, if you go back over to the output, so here's the detail report. This space right here is what's the result of this /t. So this /t here results in producing this tab stop right here. So the A on its own like that gets plugged into the %s. Now what's happening here is implicitly when you stick a variable that's an object in like this, and you say to the object, I want to print you, what happens is Java will call the toString method implicitly. Now C# works and Visual Basic work exactly the same way. They call the toString method on that object, and whatever it returns, they plug into this place here. Well, that information is what you see right here for each account in the loop. And then that gets plugged in right at that %s location. And then I provide a carriage return here so that the next one below it is below it. And then I return that string back to the caller. Now, if somebody wants to describe what a customer is, I simply return the customer's name. So even the customer has a toString method. Notice the override that you see here. That is an annotation, and an annotation tells the compiler something. And here it's telling the compiler that this method toString here is overriding its parent's toString method. This is the customer class. It doesn't extend from anything explicitly, but implicitly it extends from the object class. The object class has a toString method. So we are overriding our parent's toString to implement it the way we want it to be implemented. And we do that for all of the classes that we build. Now, a customer has a list of accounts. So what is an account? Let's take a look at that next. An account is declared as an abstract class, and that simply means you can't go into a main method and say account A equals new account. You can't create an account object. You can create a checking account or a savings account or a money market account, but you can't create an account. It's too low level. So all the account class does is it gives us common code that all of the other classes will share so that we don't have to reinvent the wheel. We don't have to duplicate all that code. And it does that, and it's there to serve as a place to store common code amongst all of the subclasses that inherit from it or extend it. Now, as the UML diagram shows, we have one constructor that takes a string and a double, which is the account number and the amount. We say account number sort of with tongue-in-cheek because it's a string. The account number really could include letters in it as well. And when you go into the constructor, we deposit the amount they pass in. Now, if they give us an amount that's bad, like a negative number, the deposit method will throw an exception. In fact, if you look at it, it's right here. Public void deposit. It accepts a double called amount to deposit, and it's capable of throwing an exception. If the amount to deposit is less than 0, it throws that exception. Otherwise, it increments the balance by the amount. If, therefore, you pass in a negative number in the constructor, which gets handed to the deposit method inside of the constructor, the deposit method will throw an exception back at the constructor. The constructor is not going to handle the exception. Notice there's no try-catch block here. Instead, it's going to pass the buck up to whoever called it. So it's going to throw the exception up. It's sort of like the hot potato. Nobody wants to touch it. If you get it, you just pass it along. So the second thing that's going to happen is it's going to set the account number, and it has no validation to deal with here, so it just sets it directly. There is a get account number, and there's also a set account number, but there's no validation on either one of them. Again, it wouldn't be a bad idea to change this to call the actual setter in case you ever want to add validation code in the future. So we have our constructor, we talked about deposit. Now withdraw is almost identical to deposit, except if the amount to withdraw is greater than the balance, we have a problem. So we throw a new exception if they want to take out more than what's there. Else, the amount to withdraw would be less than or equal to the balance implicitly. And in that case, we take the balance, set it equal to itself minus the amount to withdraw. Now there is no minimum balance issue here because this is the account class. The minimum balance issue comes along in the money market account. So we have a get account number, a set account number, and what else have we got here? A get balance. Notice there's no set balance. We don't want them to set the balance any other way but by calling deposit or withdraw. And then we have a toString method. Now notice the toString method here. Look at what we've got. It returns a string in the format of %s tab $%2f. The first parameter is the account number. The second one is the balance. We have a $sign in front of it, and we round it to the hundredths place. So that is our account class. I think I'm going to stop at this point and do a part 2 because I don't want this video to get too long. So we'll continue talking about the 4 remaining classes, actually 3 remaining with this interface, and then we'll look at the main method in the bank class and talk about the actual running program. So we'll do that in the next part.